What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 8.5, the volume of cones. So we're going to be able to find the volume of cones using a formula and then solve some real-life problems involving the volume of a cone. The first thing we need to know is a cone is a 3D shape whose base is a circle that tapers to a point to the other end. This is very similar to the volume of cylinders. Notice that you have some similarities here, except the cone is just 1/3 of the volume of a cylinder. So it's kind of like how a pyramid relates to a rectangular prism or a cube. Really, this 1/3 just means when you're finished, you're just going to divide everything by 3. And remember, for this one, you need the radius, not the diameter. Go ahead and make sure you have the cone's volume written down in your notes. And let's go ahead and get started. So we're going to find the volume of each cone. I'm going to have you watch me how to do number 1 and 2, and then you're going to try 3 and 4 on your own. So number 1, we're going to use this volume formula of 1/3 pi times radius squared times height, which just means still do your pi times radius squared times height, but then divide your answer by 3 at the end. So what I'm going to fill in first is all my numbers. I have pi is 3.14, radius squared is 5 squared, and my height is 10, and then I'm going to divide that answer by 3. I am going to round to the nearest tenth, so that's just 1 decimal place. Keep in mind that 5 squared is 25. So now I can just do this in order. So I'm going to multiply first 3.14 times 25 times 10 is 785. So if this was a cylinder, I'd leave it like that, but now I need to divide by 3. So I'm going to get 261 with a lot of 6's repeating, so we can just round that to 261.7 inches cubed. Okay? Number 2, let's solve it the same way. Again, I'll start with the same way with pi times radius squared times height, but then find my answer and divide that by 3. Notice that 6 is the diameter, so my radius I need to use is a 3. So I can do 3.14 for pi, radius squared is 3 squared, and then my height is 9, and then divide all that by 3. Keeping in mind that 3 squared is equal to 9, so now I have this, 3.14 times 9 divided by 3. 3.14 times 9 is 254.34, and then dividing that by 3 is 84.78, but to the nearest tenth, we'll just round that to 84.8 cubic feet. Okay? On these next two, I'm going to have you try these on your own, so see what you can apply with the volume formula of 1/3 pi times radius squared times your height. All right, now that we've had a chance to try number 3, let's see how we did. I'm going to do pi times radius squared times height and then divide by 3. So 3.14 times 5 squared times my height of 11 and then divide by 3. Noticing that 5 squared is 25. So let's just work this out from left to right since I'm just multiplying. 3.14 times 25 times 11 is 863.5. Then dividing by 3, I'm getting 287.8333. That's a weird looking 3. So rounded to the nearest tenth, we'll just keep it as 287.8 cubic centimeters. Okay, for my next one, number 4, my radius is not given to me. That's diameter, so I need the half that, and that'll be 6. So 3.14 times radius squared, which is 6 squared, times 12 is my height, and then dividing by 3. Or 3.14 times 36 times 12, dividing by 3. So multiplying straight across, 3.14 times 36 times 12, I'm getting 1,356.48, but then dividing that by 3, I get 452.16, but rounding that to the nearest tenth, I'm going to say 452.2 cubic kilometers. We have 2 more questions, and these 2 are both word problems, so let's go ahead and try these. You must answer a trivia question before the sand in the timer falls to the bottom. The sand falls at a rate of 50 cubic millimeters per second. how much time do you have to answer the question? Well, first we need to find the volume of the sand. Really and truthfully, you do not need this 30 here. That's the entire portion. I just am focusing on the sand for now. So pi times radius squared times height divided by 3. So 3.14 times 10 squared times 24 divided by 3, or 3.14 times 100 times 24 divided by 3. Let's go ahead and find that answer first. So 3.14 times 100 times 24 divided by 3 is going to be 2,512 cubic millimeters. So that's your volume, but then it says your sand is falling at a rate of 50 cubic millimeters per second. So all we would need to do to find the time is to take my volume and divide it by the rate, which is this 50. So 2,512 divided by 50 will give us the time of about 50.24 seconds to answer your trivia question. Okay? Last up, water leaks from a crack in a vase at a rate of 0.5 cubic inches per minute. How long does it take for 20% of the water to leak from a vase? So the first thing we got to find is the full volume. So volume is pi times radius. So it's not 4.8, it's going to be 2.4 as my radius times height, and then divide that by 3. That is going to give me 60.288 cubic inches, okay? But I want 20% of this because it says how long does it take for 20%? So I'm going to multiply this by 0.20, and that is roughly 12.0576. So now I can take this number and divide that cubic inches by 0.5 cubic inches per minute, and that'll give me about timing wise of 24.12 minutes. Okay, hopefully these questions helped you gather some thoughts about how to find volume of cylinders and how to apply it. If it did, please give this video a thumbs up and tune in next time when we look at volume of composite shapes. Have a great day.